Hello everyone, my name is Xiang. I'm currently a PhD student of the Hong Kong Polytechnic University. Today I'm pleased to give you a presentation about our recent work, Lexical Data Augmentation for Text Classification in Deep Learning. This presentation consists of 4 parts. In the first part, I shall briefly introduce the motivation of this work. The proposed method shall be demonstrated in the second part. Next, a sort of experimental results shall be discussed in part 3. Lastly, I would conclude our current work with some directions of future study. Data augmentation is a typical approach to synthesize instances which are originally not existed in dataset. Data augmentation is used to improve the performance of machine learning algorithms. In this work, we focus on lexical data augmentation. For example, based on the original instance, we can readily replace some words according to thesaurus. Then, a number of new instances can be obtained. Data augmentation can be used in a variety of data analytical tasks. In this work, we concentrate on text classification. Text classification techniques are widely used in span detection, topic modeling, sentiment analysis, and etc. Benefiting from recent sophisticated models, nowadays many deep learning methods result with extraordinary results. In the era of big data, these transformer-based methods can further benefit from tremendous training data. Even these datasets are not intensively manipulated or annotated. For instance, 13 gigabytes data was used in training BERT, and 113 gigabytes data was used in ExcelNet. But it shouldn't be neglected that in the early years of machine learning, data augmentation was applied to handle the data scarcity problem. So an interesting question is whether data augmentation still works for deep learning methods, and whether domain-specific augmented instance can further contribute to the training model. To answer these questions, we proposed a post-tag-focused lexical substitution data augmentation method. We summarize this method as a two-step augmentation. The first step is substitution candidate selection. This step follows the syntactic consistency principle to make use of post-tag constraints to select candidate words for substitution. Then in the next step, the instance generations follows the semantic consistency principle to samples from the candidate words, finally generating augmented instances. The first step can be demonstrated with a simple instance. We have an original sentence in the dataset, a great script brought down by lousy direction. Here we set the post-tag restraint as an adjective and adverb. Then great, down, and lousy are chosen to be candidates for replacement. Then we find synonyms from WordNet or other thesaurus. Here we have two collections for great and lousy. In previous step, we find two substitution lists for great and lousy. Then we use a two-step sampling to finally generate new instances. We first use a Bernoulli distribution to decide whether a word should be replaced or not. Here we will replace great. Then we use a categorical distribution to decide which word shall be used as replacements. If we use terrific as a replacement, the augmented instance should be a terrific script brought down by lousy direction. We can easily identify that the new instance generated are basically syntactic correct and has a close meaning with original sentence. The third part is performance evaluation. We select LSTM, bidirectional LSTM with attention mechanism, BERT, and Roberta as classifiers. We use accuracy as a metric. The baseline mode. 8 datasets are investigated. These datasets are used for sentiment analysis, subjectivity identification, fake news detection, and etc. They vary from training dataset instances, average sentence length, vocabulary, and class number. Here is a detailed result for 4 classifiers on different datasets. It is undoubtedly that transformer-based methods outperform recurrent neural network-based ones, and the gap is large. As for data augmentation, both EDA and PLSDA are useful to improve the accuracy, but the gain from PLSDA is more significant. The reason could be less noise is introduced for PLSDA, as it considered both syntactic and semantic consistency. This figure shows the absolute performance gains on average accuracy. It can be observed that improvements in binary classifications, such as IMDb and Twitter, are more impressive than other tasks. IMDb and Twitter, which has larger vocabulary size, can further benefit from PLSDA because the original dataset has more diversity. As for classifiers, the improvement extent of different classifiers are very close. Nevertheless, it is still worth to be mentioned that even in the condition of high accuracy, data augmentation is still effective for transformer-based method. The second set of experiments examines the effect of post-tag types to the performance. Notional words which are adjective, adverb, noun, verbs, and their combinations are considered. We grouped adjective and adverb together as they are all modifiers. As for single post-tag types, both adjective and noun substitution have good performance and the gap between is very small. For post-tag combination, adjective plus noun can be the best choice to get the best performance. The next group of experiment examined 2 sampling strategies, which are stochastic and similarity first. As it is shown in heat maps, stochastic substitutions seem to be more effective than similarity first. But similarity first strategy works well for track. This indicates that it is crucial to find the balance between semantic redundancy and implausibility. On the basis of our experimental results, we conclude our work as follows. Data augmentation can further improve the performance of deep learning models. Noun and adjective or adverb works better than verb replacement. Stochastic sampling outperforms similarity-first strategy. There are two possible future directions. The first one is investigate performance of PLSDA on more publicity-accessible datasets. And we will also explore the feasibility of PLSDA in other NLP tasks. Thank you.